We've asked Dr. Garcia y Garcia from the University of Minnesota here just to talk about corn and all the different times and the windows you can plant cover crops with corn. So he's going to talk about some of his research, and I think draw in from some of his colleagues as well. Dr. Axel Garcia y Garcia is a sustainable cropping system specialist, and you're based in Lamberton, yes?
That's correct.
Yes, great, in the Southwest. So please.
Thank you.
I'm going to turn this one off.
Okay. Thank you very much to Albert Lea Seeds for inviting me. It's exciting to be here. It's the first time, actually, that I am in this place. And I was asked to talk a little bit about cover crop seeding window for corn. As Margaret said, I'm an associate professor at the University of Minnesota in the Department of Agronomy and Plant Genetics, and my workplace is in the Southwest Research and Outreach Center in Lamberton. So most of what I do is looking at ways to use cover crops in the corn soybean rotation, conventional corn. So that said, my talk is going to be about that. So first things first. This is about cover crops. But what do we understand when we say cover crops? Well, a cover crop is basically a crop that we plant between two cash crops, but we do not harvest it. It is meant to be to provide agroecological services. And you can see there that I put it in red here, the agroecological services. We will talk a little bit about that. And basically how cover crops work is that when we terminate them, so the biomass, decomposes in the soil, and then is supposed to provide us some of those benefits that we are calling agroecological, because we are talking about nutrients, basically. And eventually, if the cover crop produces enough biomass, as the previous speaker was saying, we might be able to even reduce herbicide use because we might be able to suppress weed growth, and that would be great. So anyways, that said, I plan to talk with you today about why cover crops in corn, the challenges we have for cover crop use in Minnesota, and then I will go through some of the results we already have from research. And at the end, I will have some final remarks for us, okay? I just wanted to quickly address some of the things that my previous speakers were talking about, which is the size of our research plots at the university. That is right. They are small plots. There are several reasons. They pretty much address those reasons. There is a science reason behind that as well. Basically, we try to control everything but what we are looking at, in this case, cover crops. And of course, that is not, the last, is not the final response to what we are looking at. So after we do our research, we are supposed to scale it up to bigger plots and then eventually to farmers' fields. So that's how it works. So why cover crops in corn? I am not going to talk too much about this because you guys know much better than I do. So in Minnesota, 44% of the area on their main crops belongs to corn. The other 40+% is soybeans, and then comes the rest. So you can see that our landscape is basically corn and soybeans. If we were able to eventually put, let's say, 10% of the area under corn and soybeans with cover crops, that would be a completely different game, and we will be much better off in terms of the use of this practice. So that's the main reason why we are trying to see if we can put cover crops into the corn and soybean rotation. But the thing is that, as I was saying at the beginning, we have a lot of issues in Minnesota, but the most important one is a physical factor, and this is weather or climate in the long run. So in Minnesota, the use of cover crops in the corn soybean rotation is challenging because after we harvest the corn, or even at the beginning, we all know that there is a very narrow window of opportunity for cover crops to grow, okay? So, and there is not enough heat units for the development of those cover crops. And I will show you some of the work we've been doing using models to show that it's really very difficult, not impossible though. And this is what we can see. This is the year 2020 in Lamberton, and this is how it goes. The green growing season you see there is when we usually plant corn and soybeans. So then you can see that we want to have cover crops, and cover crops are supposed to be here at the end of the season. Oops, sorry, or here at the beginning. Okay, so because that is not possible, we are basically trying to play God here. So if we plant a cover crop, I gotta be careful now. If we plant a cover crop at the end of the season, it's gonna be something like this. We plant it, and then when it starts to grow a little bit, the season is gone. It is too cold. It's basically impossible. Or if it's a cover crop that survives our winters, it will restart growing in the spring. And again, when it starts to grow and it produces a little bit of biomass, we had to terminate it because we had to plant corn and soybeans again. Does it make sense? Why I'm saying all of that? Well, basically because I wanted to show you that this window of opportunity I was talking about is really our main issue with cover crops in the state. So at times, because I do research, I get jealous with my neighbors in the South, with Iowa, because they have a much better climate, and they can produce a lot of biomass with their cover crops. That doesn't happen very, very easy here with us. Okay, this graph is made of modeling and observed data from our research, okay? So how can we interpret this? So we took 33 years of historical weather data, observed data. We put it in a model for winter rye, and we simulated seeding winter rye from August the 1st through October the 10th, okay? So each planting date has 30 plus results. So you see this variation in each one of those graphs. It means that, for example, if you plant cereal rye for conditions in Lamberton, in this case, the 1st of August, you can have, at the end of the season, that's fall biomass, as little as 1,000 or as much as close to 4,000 pounds of dry matter per acre, okay? If you plant, I gotta be careful here, if you plant in October the 10th, this is what you are going to get, no matter which year, okay? Does it make sense? So basically, this graph is telling me that the earlier I plant my cover crop, the better it's gonna be. It's also telling me that even if I plant early, in some years, depending on the conditions, I won't be able to produce too much, probably 1,000 pounds at the most. And in some years, I might produce close to 4,000, okay? But this is the thing. If you are planting corn or soybeans, by the time you harvest your cash crop, you might be playing between here and here. If you are lucky, sometimes it goes to October. We usually, in Lamberton, in my research program, we plant cover crops here around the 20th of September. So you can see that if we plant cover crops, cereal rye in this case, on the 20th of September, which is here, so basically the biomass I am looking at, or I am going to have, is around 300, 400 pounds per acre. Is that good? I would risk to say that probably not, okay? It's really marginal growth. The previous speaker was talking about that, and he's right. I guess Sam around? Yeah. Sam is right. It's very little, okay? And there is not much we can do unless we plant earlier, but that's not the case for corn and soybeans. So that's the main issue we have with cover crops into corn. Well, just for you to see how planting date matters. This is a trial that we are doing with summer cover crops, different cover crops in Lamberton, different types of amounts of biomass and different growth rate, okay? So we planted crimson clover alone. That was planted on the 12th of July. Then cereal rye, oats, then a combination of the first three, forage radish alone, teff, pearl millet, and sorghum. So you can see that obviously pearl millet and sorghum perform very well because they are summer crops, summer cover crops. The others perform very bad, okay? But still, they perform much better than what they will do if you plant them following corn and soybeans. And the only reason for that is because because we planted earlier. It's because actually it's in the summer and they have enough time to grow. It's not the planting date, I'm sorry. It's because they have enough time to grow. So that's really very, very interesting. Didn't go? Yeah. Okay. This graph here, I promise I will go into my results, okay? It's just I wanted us all to be in the same page. This graph here shows me the growing degree days for this previous graph I show you, if we plant in August the 1st all the way to October. So if you plant in August the 1st, the accumulated growing degree days, which is the green curve there, is around 2,500, okay? But if you plant on September the 18th or 26th, which is when we do it, you have around 800 accumulated growing degree days, or heat units, as we said. Well, heat units don't help plant to grow. It's not for plant to produce biomass, okay? Heat units are for plant to develop. For example, in corn, to produce 1, 2, 3, or the next leaf, something like that, okay? But it's related with growth, with the production of biomass. So it tells us that basically we are having more time or better and a better environment for growth. But if cereal rye stops growing at the end of the season and then resumes growth in the spring and keeps going, and you harvest that cereal rye for grain, so you will see that you will need 3,200 accumulated degree days or heat units. With cover crops, that is not going to happen. With cover crops, you will be probably having less than 800 accumulated heat units, okay? So that's another reason how our environment makes this a little bit difficult, but okay. So that was my introduction. So now I'm going to show you some of our results. And I don't know if you so far have any questions. I will be more than glad to stop and discuss the thing with you. Any question? Nope. Okay, I will continue. So there are several ways we can plant cover crops into corn and soybeans, okay? One is go ahead and seed your cover crops early in the season. The other one is go ahead and seed your cover crops late in the season, both in standing corn or soybeans. Or you wait for your cash crop to be harvested and then you plant your cover crop. So basically, you can plant cover crop all the way from the beginning of the season to the end. Well, does it work? Well, let's see. So this study was about using winter oilseed crops as cover crops, okay? So the winter oilseed crops I'm talking about here were winter camelina, pennycress, and cereal rye. So when we use cereal rye here to compare the performance of pennycress and camelina. So we planted in August 31st in 2015 and May 4 in 2016, terminated, I'm sorry, and we planted also in September 14, okay? So our conclusions are there. Fall biomass was marginal for all 3 cover crops, which it does not surprise me. Compared to cereal rye, both winter oilseed crops had higher tissue nitrogen but produced significantly lower biomass, okay? But that's just because it's a different species, the tissue nitrogen. Winter camelina had significantly higher spring biomass and accumulated more N than pennycress. So that was good because it tells us that winter camelina eventually could be used as a cover crop if our objective is basically to scavenge residual nitrogen and then try to improve the quality of the environment. And also, corn yield significantly decreased, and soybean yield was not affected. So that was interesting, but we also know that soybean usually tends to perform better when it's competing with other crops. Basically, one of the main reasons is probably availability of nitrogen. So, and the crops were broadcast seeded and basically was not effective. And the problem with broadcast seeding is that you have to fulfill at least 2 things when you broadcast. The one is that you have to have much more seed than you usually do if you drill. And the other is that you hope that it will rain, but not too much. If it rains too much, seeds may just get washed out, and the establishment is not going to be good. Anyway, so that was the result of this study. We published it, and it's there. And if you want a copy, let me know, and I will be more than glad to give it to you. So this is the previous study as well, and I wanted to show here what you have is the biomass. Here, the nitrogen concentration in the tissue, and here the total nitrogen in kilograms per hectare for that biomass produced. So you guys see that in the first year in 2016 on corn, this is just for corn, I took off the soybean part. So we produce the nitrogen that was used by those cover crops was very little. So we are talking on no more than 31 kilograms per hectare, which is around 30 pounds per acre, just to make it easier. Okay? And in 2017, we went up to 36, but this nitrogen was from the winter rye or cereal rye. And the reason for that is not because cereal rye has much more nitrogen in the tissue, it's because it did produce more biomass, okay? So, and that tells us about the importance of the biomass when we are using cover crops. So the thing here is that we would like cover crops to produce as much biomass as possible. It is good for the environment. It is good when we recycle, if the objective is to recycle nutrients. And it's pretty much good for everything, soil health, and you name it. So, and you know, in the case of winter camelina, it turns out winter camelina, even though had a lot of nitrogen in its tissue, it also needs a lot of nitrogen. See, if you are going to use winter camelina as a cash crop, which we are starting to look at that, some people are starting to plant, some of our research is showing that probably you should be planning on applying 60 to 70 pounds of nitrogen to that winter camelina. So that is good, but at the same time, we are putting one more crop in the system that also needs nitrogen. So the consequences to that in the environment, they remain to be seen yet, and we are studying that, but there is no crop that doesn't need nitrogen. That's the thing. Yes, sir?
2 slides back, you showed one of your conclusions was that it reduced the corn yield, even though the termination date was May 5th. And why was that? It seemed like a fairly early termination date, right? So why would that reduce corn yield?
I don't know if everybody heard the question. Yeah. So anyway, the question is that I just showed that in this study, we terminated earlier our cover crops, and still the yield of corn was affected. Is that the question? Okay, there are several reasons. One of the most important reasons in this case was that our cover crops were competing too much with the cash crop. due to water, basically. I am not showing those results here because I wouldn't have time, but was a water issue in this case. Okay.
Dr. Garcia, can I ask about your camelina?
Yes,
your
please.
nitrogen response there is for grain yield. Do you think you'd need to put nitrogen on it if just using it for a cover crop?
Oh, okay. This question is about the winter camelina. Let me see if I can go back here. Yes, this one, right? So this camelina was harvested for grain yield. Okay. So your question again was?
Do you think you'd need nitrogen just using it as a cover crop?
Okay, whether or not it will need nitrogen if we use it just as a cover crop. No, it won't. And in fact, I do not recommend people to use any nitrogen or any other fertilizer when we are planting cover crops. Cover crops shouldn't be fertilized at all, because then if we do that, we are just negating the principle on the use of cover crop. So no fertilizer. Unless the objective is to try to have a crop that, a cash crop that, it will need much nitrogen, and we are concerned with that. Okay, another study we did was with early seeding and late seeding cover crops into corn and soybeans. So I put here, the corn stage when we seeded the cover crop at 3 different locations in Minnesota: Grand Rapids, Lumberton, and Waseca. So to summarize this, in the late seeding, we were seeding at R5, R6 corn, which is the dent and close to maturity, somewhere there. So the reason why we do that is because if we do it at maturity, which is R6, is a little bit late. We want to interseed cover crops because we want to extend the cover crop growing season. That's the objective. So we want to try to interseed it as early as possible. In the case of, okay, I have only corn here. That's good. For the early season, we were interseeding cover crops at V4, V6 corn. So the way we did that was broadcast as well, and we did incorporate with my grad students. We were raking the thing there under the corn, and our plots are not very big, so we were using here plots that were 8 rows of corn, and the length was 15 feet only, so it's doable. So cover crops in corn production systems, early and late interseeded cover crops have no effect in corn productivity, and we show you the results. And fall biomass of cover crops is marginal again. So the end season benefits are basically marginal as well because of that. Okay, and those results, and this is what we got in terms of the statistical analysis of the results. So you see on top of each one of those bars a bunch of letters. All the letters are A, means there is no significant differences between all of them. Basically, it's telling us that there is no effect on yield of corn. Or to put it in another way, if you go ahead and you interseed cover crops early or late in the season the way we did it, we would expect that your corn is not going to be affected. Yield of corn is going to be the same. Let me see this. Again, this is about early interseeding cover crops and corn productivity. So this was the cover crop that was interseeded at the V4, V6 corn. And you can see again that there is no difference whatsoever. So you see here that, no matter how good you do in trying to use your cover crops, you are not going to have too much difference. And I forgot to say that our different cover crop strategies were based on annual ryegrass and cereal rye. And each one of those cover crops were mixed with crimson clover, which is the CC, and forage radish, okay? And of course, each one of those had a no cover, which is the ARNC or the CRNC. No difference whatsoever, so that was okay as well. Then we thought that probably if we late seed cover crops into corn, but we also look at tillage practices, we might be able to find some differences, and eventually our cover crops will produce better as well. So we had a combination of conventional till, no till, and strip till, a combination of tillage with different cover crop practices, which you see here in the x-axis, okay? And again, no differences. When did we see those? We see that in September the 1st, August 15, and September 15 of 17, 18, and 19. No difference, okay? Well, one might ask me why you guys are not finding differences. There are huge differences in the planting dates, and there is no difference in the response of the cash crop on these things. So it's again, I want to come back to the same thing. It's just, if you look in August you have temperature here, which helps the development of crops, and you also have solar radiation or light around here as well. Very quickly, they both go down. And along with that, the growth of crops. I mean, for a good reason, nature doesn't produce pretty much anything during the winter season, right? But this is the interesting thing. We know that the different seeding dates for cover crops in corn, they are not telling us too much yet, but I will show you what we are doing right now in a minute. But we also know that they can help the environment, okay? It needs several things to happen. One of those things is that we have to keep trying and doing it until we become very good at doing that. And so we also monitor, the concentration of nitrate at 3 feet depth, okay? And we analyze those data, and you can see here that we had significant differences in the concentration of nitrate at 3 feet in some few instances only. That was, those stars there means significant difference, okay? So this pink bar here is the concentration of nitrate, in the plots where we had no cover crop. So how do we interpret that? It means that the higher the nitrate there at 3 feet, the higher the possibility that we are losing nitrogen, and we are eventually polluting the environment, eventually. Now, few were significantly different, but in most instances, the concentration of that nitrate where we didn't have cover crops was higher, and I show you that with those arrows there. So, which means the other arrows are different cover crop treatments, which means that cover crop really help, right? And also it makes sense because even if cover crop just grows a little bit like this, that cover crop needed nitrogen for growth. And that nitrogen could only have come from the soil, okay? And that's why we don't want to put fertilizer in the cover crop. We want the cover crop to use whatever nitrogen is residual and is in the soil. We want the cover crop to do its job in this case. So it works, but it's not very, we cannot feel it very well. So we are doing this trial because some of our people there ask us if we can look at when will be the best timing to seed cover crops early in the season. So this is in 2021 was the third year we did this trial. So what we do is we plant corn, this is on corn only, and then we seed the cover crop. One treatment is along with corn, we plant corn and cover crop at the same time. So that is the, what is this? Well, there is the first one, controlled no cover crop, okay? Then we plant corn and the cover crop together. That's May 1st. Then at V2, that was June 2, and at V4, June the 15th. And also we try V6 and V8. So you can see, if you plant the cover crop along with your corn, you're done. So it reduces 80 to 90% yield. just that. It's very, very simple. Interestingly, interestingly enough, if you plant at V2, it reduces a little bit yield, but not much. And that has been consistently for 3 years. That includes this year, which was a dry year. And if you plant at V4, it grows very little, but it still grows a little bit. And from V6 and on, basically growth is very marginal because shade issues. Grasses are not good to grow under shade. So we have here, one side is grass, the other is crimson clover. Crimson clover does better, shaded. And also, very interesting, crimson clover actually stresses more the corn. Because it grows much better, it uses more water. So the water is the problem with crimson clover if you interseed, okay? Let's say in this trial here, in the treatment where I put cover crop along with the corn, I guess my corn yield for that year was around 40 bushels or less per acre, okay? With the annual ryegrass. With the crimson clover was less, 30 bushels or something like that. And it was very clear. Now, the crimson clover comes really very beautiful. You can see here even flowering, okay? But don't get mistaken with this, because if the crimson clover is flowering, it looks beautiful at field, it does not mean that it's giving us any benefit this year. The benefit comes after. The year we see the crimson clover in this case, because it's a legume crop, is basically growing and is using resources even if it's producing its own nitrogen. So it will need to decompose and then get back a little bit of what it used. But as it's similar to soybeans, let's say, whatever they produce, they used it. So there is not much that is going to be left anyways. But it does very well. It really does very well, produces a lot of biomass. In the long run, I believe, it's good, for soil health issues. So please don't try to put corn and soybeans together because it doesn't work. Even V2 is not really the best one. From V4 to V6, it goes pretty well. And this is just another view of how it looks like later in the season. You can see that basically in some pictures there is not much, and in others, there is not much of the cash crop as well. And again, another view of that. Let me see if I can do it from here. You see no, you don't see it. But anyways, so the one in the middle is the control, and there we have the annual ryegrass seeded along with the corn. You see the corn looks pretty bad. And here, the crimson clover is looking much better, but the yield of corn was affected. One more here. So this is the amount of biomass that it was produced by the cover crops. You can see how much biomass was produced in this crimson clover, 3,300, and then there for the cereal rye, 2,800. So much more biomass from the crimson clover because it basically does better when it's shaded. And our corn looked like this. So you see the canopy height, it was really, really affected. If you look at this, it looks like this as compared to the control. Let me do this way. And if we compare both the annual ryegrass and the crimson clover, it's like that. Okay. If we look at another study that was planted, corn was planted in June the 1st, this is effect of early interseeded cover crops on corn productivity. Again, no effect on yield of corn at all. So, it's interesting to see like that, but let me see here. If you look in another year, you will see like this. And this is in bushels per acre of corn. You see here how much we produce when we plant cover crop along with corn. See, the yield of corn is really reduced considerably. This is in 2020, which was a little bit dry year, and this is 2021. That's what we got. 2021 was terrible, okay? At our station, our corn our average yield of corn is around 200 bushels, including our commercial plots and our experimental plots. This year, our average yield was 100 because of drought. Yeah, it was terrible. And so far, we have received 2/3 of the rainfall that we should have received so far in a normal year. So it was really very, very dry. Okay, before I am done, I wanted to spend a couple of minutes to talk to you about planting green, which also was discussed in the previous talks. So what is planting green? It's basically an inner seeding. So what we do is we plant corn or soybeans into standing cover crops in this case. Why do we want to do that? So the main reason we want to do that is because we want to extend the growing season of the cover crops. We want to make sure that we have the most of the season for cover crops without affecting the cash crop, obviously. So this study was conducted in 2020, and what we did here was, we planted our cover crops in 2019, and then we terminated the cover crops in 2020 at 3 different dates, okay? So what we did was we terminated, we burned it down with glyphosate. Most of what we do, we use glyphosate to terminate cover crops and to control weeds. We terminated on May the 2nd, May 12th, and May 21st. But we planted corn and soybeans on May 12th, okay? So what happened with that is that we gave the opportunity for the cash crop to be planted where we didn't have any cover crop, and also we had our cash crop planted into standing cover crops for around 8 to 10 days, something like that. So results were, in terms of here, the biomass, but if you look here at the most important thing, the yield of corn was considerably affected, okay? If the corn that was planted green with the termination of the cover crop on May 21st was significantly affected, it produced very little yield. The other two did it well, but still, there were some significant differences in between. Soybeans, on the other hand, was not affected. Soybeans did well, so they did it well. So among other things, this study is telling us that how long the cash crop is going to be under the cover crop matters. So we have to be very careful with that, because if we leave basically the corn in this case too long, the likelihood of failure is very high, okay? So we decided to do this experiment again in the following year, which was from 20 to 2021. And let me see if this is the thing. Yeah, this is the thing. And this is what we got. So first, we have the biomass of the cover crop in the fall. You see, when we planted the cover crop in September the 4th, because we had different planting dates, we produced around more than 1,000 kilograms, okay? Pounds, of dry matter per acre. It did very well. When we planted on September 16th, it went down to more than half. I'm looking at here. This is fall biomass, okay? And then for September 24th, even less, and October the 5th, almost nothing. So the earlier we seeded, the better it was. And then each one of those planting dates were used to plant corn and soybeans the following year. That was in 2021, I'm sorry. This is just for corn. This is what we did. We terminated the cover crop on May the 7th here. Then we mowed the cover crop, and we incorporated the residue. I don't know if I am explaining myself. And this is what we got. The other part, we terminated late, and we planted green. So what we did is we went ahead, planted corn. Immediately, we terminated the cover crop, okay? We did it immediately. We didn't wait. The same day we planted, we terminated. And these are the results in terms of production, okay? You can see that we produced a lot. This is not statistically analyzed yet because I was in a hurry. I wanted to show it to you. I didn't have time. But it basically is telling me that we did it very well, even if we planted late and if we planted green. This is 1 year of results, and it was a very dry year. I could visually see that, I guess I have some pictures, I guess. Let me see, I don't remember. But that there were very huge differences between the corn where we incorporated the residue and the corn that was not incorporated. But the main issue here was because we had a lot of biomass on top of on the ground, and it saved us water. So evaporation was less as compared to the other one, and that helped a lot. So if you can see here again, these are the results we can see for these different planting dates, but I wanted to show you here now. If not, we are not going to have time to discuss. Yeah. This picture here tells you how our corn looked like. This is the corn that was planted green. It looked like this. I didn't believe that we will make it. And at the end, this is what we got, okay? So you can see here, cover crop seeding date, corn was planted on May the 18th. So the red or the orange one is cover crop terminated on May 18th, and the blue one is cover crop terminated on May the 7th. The May 18th the corn was planted green. Consistently, we did it a little bit better than in the other. But as I said, it's 1 year, a dry year, but it's encouraging to me. See, the other thing is that we were able to produce way more biomass of cover crops than just terminating earlier. So the take-home message here, guys, is that for conditions in Minnesota, in most part of Minnesota, the first 2 weeks of May are key for cover crops growth. If we were able to provide cover crops with those 2 weeks of May and then have our cash crop, I guess our cover crops will work way better than what they are doing so far. The problem with that approach, obviously, is that we risk, having eventually some issues with our cash crop, because the earlier we plant, the better it's going to be. This first evidence tells us that it's possible, that there is even a positive result of this, but it's too early to conclude that it works. Well, anyways, so my final remarks are that cover crops may be seeded early or late in the corn growing season. And for conditions in Minnesota, research shows that biomass production is higher if seeding at V4, V6 corn. That means early in the season. So you can see that I am not talking about planting dates here, because usually to talk on dates is not the best way to do it. It's better to talk in terms of the phenology or growth stage of the corn in this case, because that sticks much better to the conditions where we are doing it. Also, seeding at R5, R6 corn late in the season could work. Seeding after corn harvest, so my suggestion is the sooner the better, okay? But our window of opportunity is very narrow. Mid-September, if possible. It shows that mid-September looks like it's okay. From late September, establishment and fall benefits are marginal, but we can still expect some growth in the spring. Early and late seeded cover crops have little to no effect on yield of corn, as we saw it, and consistently research tells us that we are going to be okay if we do it that way. So, and as I was saying, in the region, the first 2 weeks of May are key for cover crops growth, okay? But more research is needed to determine the feasibility of best management practices for that. As I said at the beginning, the more often we do this, the better we get at, okay? And planting green is a promising practice, actually. It's really promising, but the results are not conclusive yet, at least for me. I really like the practice. It looks like we have a good opportunity there, but we still have to be very careful on how this goes. But it looks like it's a promising thing for us. So that's what I have for you today. I hope I fulfill your expectations, and if you have more, if you would like to look more, you can go to this website. I also would like to take the opportunity to thank you, my sponsors, which is Minnesota soybean growers, corn growers, the MDA, and also Albert Lea. Albert Lea helps us with some of our trials for the summer crops I was showing you here, and we appreciate that. So thank you very much. I am open to questions, and I will try to respond at the best of my knowledge. Thank you.
Axel, could you just go back a couple slides?
Yeah, sure.
Let's
see.
There you go.
Okay.
So this is really counterintuitive to me, because what it looks like is you terminated it. When you terminated 11 days later, you actually got more yield out of the corn.
That is right. Yeah.
And so that doesn't. Does anybody else struggle with that?
Yeah. No. So the observation here is that it looks like probably should be the other way, right? Because we planted pretty late that corn. The main reason here is water. 2021 was extremely dry, okay? So basically we had huge, spaces between, the soil was cracked because it was too dry. And I could notice that in the treatments where we didn't incorporate the residue of the cover crop, the corn starting by the end of July was doing much better. So we didn't have rainfall in Lamberton for 90 days. We received like half an inch in 90 days, okay? And the that was incorporated was basically, you could see the plants, the corn plants that were under really lots of water stress. That was the reason, and that's why I was trying to emphasize that this is 1 year of results, and we should be very careful with that. I would love to see this under normal conditions, actually.
So are you saying the rye or the cover crop was essentially creating a little microclimate that was protecting the corn seedlings? Because so just intuitively, yeah, you would think that you would just have more, with the cover crop still growing around the corn, you would have more competition with the corn, and classically, the more competition there is with early season growth in corn, the lower the yield gets. So
yeah, you're right.
Yeah.
Okay, I guess it's back to normal. This is the thing. Cereal rye is really very interesting. I mean, cereal rye and other grasses as well in terms of competition. So we hear a lot that corn following cereal rye is a recipe for failure, right? Even if we wait 8 days, 10 days, 2 weeks, well, it depends. Someone was talking there, some of the gentlemen in the public there, that somewhere here, I guess, was, that if we are able to put the nitrogen, what I did here is I terminated and I fertilized, okay? I put the full nitrogen at once right after I planted and terminated the cover crop. The other thing is that why we did that, because there are evidences from research that the problem with cereal rye is underground, okay? The problem is in the roots, the biomass of the roots, but not exactly the amount of biomass. It's because the carbon-nitrogen ratio of the biomass roots is very high. There is more carbon than nitrogen. As a consequence of that, the microbes in the soil, they will need to get nitrogen somewhere else, which is in the surrounding soil there, to break down that residue, okay? So at the end, what happens is that we will have less nitrogen available for our corn. So my rationale was, okay, if that's the case, I'm gonna put the nitrogen right away and see what happens. And it did well. But as I said, I don't want to conclude with this. I am excited, but it's the first year. But you are right, this is kind of odd. But that's exactly what happens. Good question, good observation as well. Any other? No more questions? Yes, sir.
Thank you. You mentioned a little bit about the herbicides that you're using. Did I take it that you're on the corn that you're interseeding, like at V4, you're just using Roundup, both probably burn down pre-plant and to clean up before you do the interseeding?
I didn't get your question. Can you please repeat it?
Your herbicide program where you're doing the V4
Yes.
interseeding, is that just with Roundup, like is this like
Yes.
GT corn, and you're doing a Roundup cleanup before you do the cover crop interseeding?
Let me see. Before I do the interseeding,
Or are
no.
you just spraying before planting?
I spray before planting.
Okay.
Yeah, that's what I do. And I use the glyphosate to terminate the cover crops as well.
Right.
Yes, that's what we do. Yeah.
Right.
In both cases, yes.
Any comments? Okay, so that could work. That could work with conventional corn or GT corn.
Right.
Any comments on any other herbicide? Have you tried any other herbicide programs with that V4 interseeding?
I have not, but that's a good question because 3 years ago in one of my trials, my technician there had to apply. That was the only year, another herbicide, and I apologize, I don't know which one he did apply because we were having issues with weeds, so they applied something else, but I don't remember which one was it. Mm-hmm. Yeah, but most of the time, I try to keep it just with glyphosate because it is easier for me, and I have to standardize my management so my results make more sense in terms of when I do the stats, you know.
Did what they applied, did that affect your interseeding at all?
No, it did not.
Okay.
It did not. Mm-hmm. No, good question.
Axel, I have a human management question for you.
Yes, please.
Well, as Sam said, rye before corn, you need to be a student of that to learn to do it. And my feeling is it's not for the faint of heart. But one thing, it seems like people better be scouting that corn and looking for cutworms and armyworms pretty darn regularly. So
Yes.
how are we going to train people to do that?
Right, yes.
People are so unhappy, when they find armyworms have stripped their corn. Well, if they were scouting, they would have seen them beforehand. So there's a human behavioral change question for you.
Yes, please. Well, in one of our trials, we had insect traps all around. So we had insect traps, in the plant, in the soil, and everywhere. And I was being helped by an entomologist to do that. And then we analyzed the data. That was for an early seeding cover crops in corn, seeding at V4, V6. And this experiment was done in 3 locations in Minnesota during 3 years, and it was supported by the corn growers. And our results were not, we concluded that there was no effect on anything because of the cover crops. It was basically the same. I don't know if that responds to your question, but I did not want to keep looking at that because it's a lot of work and we didn't see anything for 3 years.
Yeah, my concern is for the fall planted rye that may attract armyworms or cutworms in the spring, and then planting green corn into that.
Yeah, we did not see anything, no.
And it's so seems randomly arranged since they fly in every spring, but it does happen, and if you don't see it for 5 years or 6 years, you get lax on scouting.
That is true. What happens is that that type of when you work with insects, it's very difficult to conclude because it's a pretty dynamic and very it's a pretty dynamic phenomenon that is highly driven by conditions, in specific conditions you might have at field, those kind of things. So probably you guys, most of you know Bruce Potter, who works in my station. He does that things, and he is always, looking at that day and night and all years. And sometimes he gets frustrated because the data says a lot or says nothing. But most of the time, I don't see any issue with cover crops and insects at all, either beneficial or non-beneficial. So it's pretty much the same from what I've found so far. Yeah.
Other questions? If not, I want to thank you very much.
No, thank you. Yeah, it was fun. Thank you.